So in part one, we talked about the fact that the core issue in navigation really is knowing which way to steer. When I get to the fork in the road, do I go left or do I go right? Which way do I point the boat? Which direction do I fly the airplane? That's the bottom line. Now, in order to figure out which way to steer, you generally need some sort of reference for direction. And knowing one's position, velocity, orientation can be very helpful in the process of doing that. And of course, nowadays what we have are navigation systems, and it can be a particular standalone unit in our car, or it can be an app on our smartphone. But for the bulk of human history, we perform navigation without having very precise knowledge of position. Now, the ancient Polynesians were able to cross very large distances in the Pacific Ocean, and they could successfully arrive at some tiny island, hundreds or many hundreds of miles from their point of departure. And they could succeed in this very challenging navigation task primarily by reference to the stars. So the question is, how do they do that? And in general, what is this business of navigating with respect to the stars? Well, as just one simple example, let's take a look at the North Star. And to put it really simply, the North Star would allow you to determine latitude, or more simply, it allow you to determine how far you were north or south between the equator and the North Pole. If you're up close to the North Pole, the North Star would look very high and appear very high in the sky. If you were closer to the equator, the North Star would be very low on the horizon. Before we go on, let's make sure everybody's on the same page with regard to latitude and longitude. And so here are lines of constant latitude, and so the equator, for example, is the line of 0 latitude. If you're up at 45 degrees north latitude, then you're halfway between the equator and the North Pole. The North Pole itself would be 90 degrees north latitude. So latitude's telling you how far you are north or south on the Earth. Now, by contrast, longitude, these vertical lines, circles around the Earth, and a particular line of longitude will tell you how far you are east or west of the prime meridian or the Greenwich meridian. So the bottom line is that latitude is an indication of how far you are north or south on the Earth, and then longitude is an indication of how far you are east or west on the Earth. All right, well, how does this work with respect to the stars? So, as I said, if you're looking at the North Star, if you're up at the North Pole, then the North Star is going to appear directly overhead. Whereas if you're further south, if you're at a lower latitude, then that angle at which you see the North Star, that North Star is going to appear lower and lower on the horizon. Now, it's very important that you do this with respect to the North Star because it's the only one that stays put in for a particular location on the Earth. As the Earth rotates, all the other stars appear to move in the sky, but the North Star doesn't. Let's take a look at that. So here's a fascinating image, and it's a time lapse over a significant portion of the evening. And all of these guys are stars that are appearing to move through the sky as the Earth turns. However, this is the North Star, and over the course of the evening, the North Star effectively stays still. And that's the key. That's why we use it. If we're up at a high latitude, that North Star appears high up in the sky. If we're down south, closer to the equator, then that North Star appears lower on the horizon. And so if you can measure that angle that the star is above the horizon, then you can figure out your latitude. So how do we do that? Well, here was an early instrument that they used for these purposes. This was called a cross staff, and you had this cross piece, and you could move it back or forth along this long piece. And the idea was to take the bottom part and put it on the horizon, and then you'd move the cross piece so that the top of the cross piece was lined up from your eye, lined up to the object of interest, the North Star, for example. And then depending on how far you had, if the object was low on the horizon, you'd have to move this cross piece out farther away from you. If the object was very high in the sky, you'd move the cross piece much closer to you. And then there were markings on it that you could use to measure that angle. Well, this was another device, the astrolabe, that was used for similar purposes. And again, you'd sight along it to the object of interest, and then you could measure the angle from the disk. All right, so what we have done is seen how we can use the measurement of the angle of the North Star above the horizon to determine our latitude. Now, you may be thinking, well, okay, that's great if you're in the northern hemisphere, but what if you're in the southern hemisphere? Well, there are other constellations and stars that were used for navigation in the southern hemisphere, but the principle, it's the same basic idea. However, we haven't said anything about longitude. So these star sightings work for determining latitude north-south, but how are we going to determine longitude? How do we determine east-west? And it turns out for that, what you really need is a good clock, and we'll talk about that in the next part.